Hello and welcome to lesson 3, all about the importance of vegetation on coastlines. Today we're going to be looking at what we mean by vegetation, the stages of succession, examples of vegetation, how that vegetation stabilises the coastline, and then we're going to tie it all together with an exam question at the end. So first of all, we're just going to talk about what is vegetation. So vegetation is just all about the plants that grow, and specifically for this we're looking at the plants that grow along that coastline, so from the beach all the way up to climax vegetation, which is like a forest. And looking at this slide here, we're looking at the difference between the high tides and the low tides. So you might get asked about how tides affect the vegetation, so it's important that you write that it adds complexity, as a high tide will drown and destroy quite a lot of those plants that are closest to the sea. And if a storm happens as well, that increases the risk, as more water equals more damage. Plants can't survive on these sorts of coastlines, especially if it's a high energy coastline with those hard crashing waves scouring away at the sediment as well. And this basically affects those weaker non-adapted plants that are further inland, as they get exposed to more sea conditions, so heavy storm conditions, wind, rain. And then on a low tide, these low energy coastlines, this is the key location for vegetation to grow. So they're ideal for plants to grow because plants growing is a delicate, it's a slow process, especially with these pioneer plants and then the plants that subsequently follow. Because it's such a slow process, they need these calm conditions. So this is probably the most important diagram on the course, and this basically shows you all the different stages of which plants and vegetation can thrive on a coastline, and this is called the stages of succession. This is also a thing that comes up on the A-level biology course, so it's pretty important there too. So what happens is we start off with the embryo dune. This is the part closest to the sea. This is normally where you'd see all your tourists go in, sit on the beach sunbathing. This is the typical sort of beach environment, and this is where this process begins. So when the rocks all collect from being pushed onto the land by the sea, from that swash from the sea, they over time stop and trap loads of sediment and sand being blown. And as they do this, they create this sort of sheltered environment for the first plants to grow. So these are called the pioneer species, which basically means they're just the first ones to grow. So I've got an example underneath every stage here of a different type of plant. Now, it is important in the exam, if you're writing the answers about this, if you get a question about this, that you use specific examples. So the prickly saltwort is the first sort of plant that would be growing in this embryo dune. It's very small, it's very prickly, hence the name, so animals aren't eating it, and it's adapted to survive closest to the sea. So it's got very waxy leaves, it's got really like embedded roots, like the roots are really big, and like I say, it's prickly, so animals don't eat it. So as these plants grow, they then create more shelter, sort of like a positive multiplier effect. They create even more shelter, and you end up with the dune starting to go up a bit. And this is where you see other plants growing. So in the foredune, in that second stage, you see a different type of plant, lime grass. So now lime grass is a bit like the marram grass, in the sense that they both have really, really long roots that stretch out, keep that sediment together, and we'll look at that in a second in terms of how that protects the coastline. But lime grass, very waxy, so it protects it from the salt spray from the sea. And then in the yellow dune, you get the marram grass, which is just a bigger, more established version of that lime grass. Different species, but it's the same sort of premise again here. The waxy leaves, these are the typical ones you see on sand dunes. They're really tall, and they stop they basically break the wind, they shelter all the plants that come behind it. They're really, really vital to this stage of succession. They're really, really vital to this stage of succession. Now, stages 1, 2, and 3 have typical sandy soil, so it's just sand, and that then evolves into this sandy soil with organic matter for the grey dune. So the grey dune is quite a big part of this stage of succession. You see more shrubs here, some more bushes. You get lots of plants growing really close to the soil, so you get sort of mosses growing on top of the soil. And it's just sand and soil mixed together, essentially, in this stage. Then you get this thing called a dune slack. This is normally where you get ponds, small little streams, things like that are collecting as they are just below the water table. And this is where you get some more aquatic sort of plants along this stage of succession. So you get marsh pennywort. Now that is an aquatic plant. It can grow both underwater and on land, so that's really good. And then this final stage, climax vegetation. So I've said pine trees here because pine trees are the most typically seen closer to the coast. You see quite a lot of pine cones and stuff on the floor near the coastline. There's quite a lot of trees, but most of them are pine trees because they can grow in harsher conditions. So they are adapted to being close to the sea, especially in the UK. So the climax vegetation just means the most types of plants that can grow in that space. And stages 5 and 6 both have your typical established soil, so the soil that you'd see out in your back garden. So it's the same sort of soil there. So how does vegetation stabilise the coastline? So I've split this into three. For so how does vegetation stabilise the coastline? I've split this into 3 different reasons. The first reason is probably the most important one, and this is all about how the roots bind that sediment together. This is called flocculation. It's a very nice word. This keeps the sediment together, so it's not loose, so the sediment isn't blowing around. So if the roots were weak, then you'd end up with massive holes and massive gaps in the sand dune. So the roots of marram grass, for example, are 70% larger than the actual plant itself. That's due to a lack of water, really, so the roots can find pockets of water, but that inadvertently also binds all that soil and sand, together. And then the second reason why plants stabilise the coastline is they act as a windbreaker, sort of like those rocks at that first stage. So as the wind travels along the beach carrying all that sand with it, once it hits this plant, it then loses all that energy, drops that sand behind the plant, and then when you go to the beach, you might see this yourself. So if you look at the plants, you might see like a little mound of sand just collecting behind it. And that then provides more shelter for newer plants to grow on it and for the plants to expand and become more established. And the third reason why vegetation helps to stabilise the coastline is this process again of the wind, this shielding process, but not shield it directly from the wind, but actually from what the wind's carrying with it. So as the wind travels across the water, it picks up grains of salt, so salt from the seawater. And it basically stops that salt spray from going beyond the marram grass. So we're using marram grass as an example here because it does all 3 of these things. So it traps that salt spray, and this is important because if the soil has too much salt in it, then that makes the soil unbalanced for other plants to grow. So it almost is like a poison to most plants. So marram grass can grow in salty conditions, but most plants, like this little flower that I've drawn, cannot grow with salt spray on it. Just kill it. Too much sodium in the soil would kill the plant. So if we were to look at an exam question, so explain the importance of vegetation in stabilising sandy coastlines, the first thing I'd look at here is this word explain. So whenever you get a question in the exam that asks you to explain anything, it's always important to use the word because. You're never going to pick up on marks if you're not using the word because. Because if you use the word because, it forces you to explain what you've put. So this is how you pick up on the marks. And then it says here the importance of vegetation. So this would mean you'd have to name some. So you'd have to name drop some of these. So you'd have to It also says about the importance of vegetation, and you definitely have to name drop some of these. So I'm going to use marram grass. Why is this doing this? So I'm going to use So here we have an example of an exam question. Now it says explain the importance of vegetation in stabilising sandy coastlines. First thing I've done here is highlight the word explain. So we need to be using the words because and so here. And in doing so, you're forcing yourself to explain rather than just describe. So you're getting those extra marks. It also says the importance of vegetation. So you might want to identify some of these in the introduction to get those higher marks. And then it also says about stabilising sandy coastlines. So you might want to also identify in your introduction that stabilising certain coastlines, such as that low energy and low tide coastline, because this is the only place where these plants can grow. Okay? So I've put it firstly, secondly, and thirdly. Firstly, it's basically that image that we looked at before. So firstly, it's all about roots binding the sediment together, flocculation. This stabilises the coastline because it keeps all the sediment together so it doesn't get blown away, so more plants can grow. Secondly, plants adapted to survive closest to the sea shield other plants from stormy and windy conditions. This stabilises the coastline because it allows for more plants to grow, stopping even more sediment from being stripped away from the coast. Thirdly, plants adapted to survive coastal... I've done it wrong. Again, I've done it wrong. So here we have an equation, brilliant. So here we have an exam question that says explain the importance of vegetation in stabilising sandy coastlines. The first thing I've done here is unpick that question. So it says to explain, and all I've done here is highlight it and put because and so. By doing so, you're almost forcing yourself to make sure you're explaining. So you're not just doing detailed answers. So you're actually answering the question. The next thing I've highlighted here is what I'd put in the introduction. So I'd do a few sentences in an introduction, identify some vegetation examples. So I've gone for marram grass, prickly saltwort, and you would definitely get a mark for that. So the things yellow +1, that is how you'd get the marks for this. And I'd also, in the introduction, put about what it means to stabilise. So I talk about that vegetation only can really stabilise those low energy, low tidal coastlines. That would also get you a mark. And the firstly, secondly, and thirdly is actually this diagram here. So this diagram that we just previously looked at, essentially put into an answer form. So the first thing I've gone for is how roots bind the sediment together. This is probably the easiest one to start with. The process of flocculation, that would get you 1 mark. That's your detailed bit. Then you'd have to go into the explanation. So you'd have to say that this stabilises the coastline because it keeps all the sediment together so it does not get blown away, so more plants can grow. Secondly, I've gone for how plants are adapted to survive closest to the sea and how they shield the plants behind it from those really windy conditions that you find at the coast. That would get you a mark. Your second mark for that bit would be by explaining that it allows more plants to grow behind it, so even more sediment can be trapped, so that it's not taken away from the coastline. And thirdly, it's all about how, again, it's the shielding process, but this time not just shielding it from the wind. We're going one step beyond this to get an even better answer, to say that it's even shielding it from the salt spray, from the ocean, from the sea. And this stabilises the coastline because it protects the soil from being poisoned by the salt, and then that then leads to more plants being able to grow. So hopefully you've understood how this question's been laid out. That's how you'd get all 8 marks. They will only really ask about how it would stabilise the coastline. They won't want to know how things are formed, I don't think. So, yeah. No.